Optimization, another interesting topic just like related rates. To optimize something means to maximize or minimize some aspect of it. What is the size of the most profitable production run? What is the least expensive shape for an oil can? What is the stiffest rectangular beam we can cut from a 12-inch log? Like my penis. We usually answer such questions by finding the greatest or smallest value of some function that we have used to model a situation. A good one is fabricating a box. So that means creating a box from a sheet of paper, a sheet of whatever you've got. So let's say we've got an open top box is to be made by cutting congruent, means the same squares of side length x from the corners of a 20 by 20 inch sheet of tin and bending up the sides. So how large should the squares be to make the box hold as much as possible? So the best thing to do right at first is take and make your sheet. I mean, it doesn't have to be drawn to scale, but let's say this right here is 20 and this right here is 25. Okay? So we want to maximize the volume. So you need to figure out, first step is trying to figure out what you're doing. And we want to maximize our volume in this example. So what is volume? That's length times width times height. So we want to cause congruent squares on the side everywhere. And we know that their length is x. So we know the height is going to be x. So volume equals x times. So what's our length? Well, 2x is going to be cut off from each side. So we should do 20 minus 2x, 25 minus 2x. So this equation fully written out and equals 4x cubed. I've done this beforehand, so I mean this is just it foiled out. So 4x cubed minus 90x squared plus 500x. So we know 2x cannot exceed 20, because if it did, then you wouldn't have a length. So we know that x can be equal to, it's from 0 to 10. So first we need to find the derivative, because the derivative, if you remember, can find maximums and minimums by horizontal tangents. And then using the double, and then we can find out if it's concave up or concave down. So we've got this, we need to maximize it. So v prime of x equals 12x squared minus 180x plus 500. Where does this equal 0? You're going to make it equal to 0, and you're actually going to have to use the quadratic equation on this, or you can use your calculator. So where is v prime of x equals 0? I'll just do it for you. At one point, x equals it at about 3.68, and another point is at 11.32. Now you're probably sitting here thinking to yourself, oh, that's it. We should make the x's 11.32. But if you remember what we did before that was vital, is we know that 2x couldn't go over 20. And if you put 11 in there, you're already at 22 point something. So you can't do that, and you automatically have a negative length. So you know that it has to be 3.68. Now, a lot of times an AP question will tell you that you need to prove that this is a maximum. So you take the second derivative of this for the concavity of something. So you got 24x minus 180, and that's all there is for that. So you make that equal to 0. No, I'm sorry, you don't. You plug in 3.68. And as you know, 25 times 3 isn't even over 180. So 24 times 3.68 is not going to go over 180. So you know you're going to have a negative number. I'm not saying that it matters. You should try to figure out what the exact number is. I'm doing this for time's sake. But it's going to be a negative number, which means it's concave down, which means that it is a maximum. So now you know that the cutout square should be about 3.68 inches on a side to give the maximum volume. Another one you can do is, let me turn the page here, give me a couple seconds, is inscribed rectangles. Okay? So, lamppost. Let's say we have a isosceles right triangle on a graph. This is at -1, this is at 1, this is 0, this is the y, this is B, this is A, And this is P, which is X, question mark, and this is X. So, this shows a rectangle inscribed in an isosceles right triangle whose hypotenuse is 2 units long. Hypotenuse being this side. Hopefully you know that from geometry. So, what is the y-coordinate in P in terms of X? So it's basically writing an equation for lie A and B. We don't have to worry about that. So we need to figure out what is the largest area the rectangle can have and what are its dimensions. So, how do you optimize this? I never worked this one out, so we're gonna work it out together. I may stop at certain points, but this is me trying to figure out. So we're trying to maximize the area. Well, the area of a rectangle is length times width. We all know that. So our length is going to be 2x, and our width is going to be y. So, how do we figure this out? So, what do we have here right now? What do we have, Jesse?
We have a rectangle and 2 triangles. Or 1 triangle.
So, how do we solve this? We want to figure out the area and how to maximize it.
I would say subtract from the triangle. Area, no. I'm thinking.
Stop the video.